Greetings humans, Ryan Lemon back here with you. Linear equations in two variables is what we're going to be talking about today. Well, what is a linear equation in two variables? Most oftentimes you have represented a y equals 3x plus 2, something like this, where if you put in some number for x, if you put in some number for x, you will know the result or the output of some number for y. And it said that y depends and is the dependent variable on whatever x is. So x is independent of y, but y depends on the value that you put in this equation for x. Okay, so this makes a little bit of a sense. Let's try to use it. Okay, so here's the same equation, y equals 3x plus 2. If we were wondering if this here point is a solution, if we didn't know, and we were wondering, hey, does negative 2 for x and negative 4 for y work with this here equation? Well, let's see. Let's take x as the input, put it into this equation, and see if the resulting y is worth negative 4. Okay, well, we're going to substitute in negative 4 for y. Whenever I plug something in to an expression, I try to use parentheses so I don't get confused, especially when it comes to the sign. Okay, we have negative 4 equals negative 6 plus 2, and is negative 4 equal to negative 4? Yes, so it looks like the point negative 2, negative 4 satisfies the equation, so it is a solution. Cool beans. Humans, one of the most important algebraic concepts is this idea that a function sometimes has a rule to where if you input an idea, it's acted on by this rule, acted on here, and then the output is some value y. So again, you input some member of the domain, and it's acted on in some way, and the output is this member of the range we call y. So it's not terribly confusing, but let's take a look at what it means. So if you have that same idea, y equals 3x plus 2, maybe you think to yourself, what dictates the value of y? What's the rule? Well, the rule is you take x and you multiply 3, and then you add 2. That's the rule. So if we wanted to list possible values for x as they relate to y, relation, function, a function is a relation. So let's see. If you had some arbitrary values of x, what y's would you get based on the rule that's happening to x? If you put in a negative 2 in there for x, what would happen? A negative 2 in here for x, and you add with 2. Okay, you've got negative 6 here, and 2 is negative 4 for y. So you can see the ordered pair is formed and is true for this equation. The ordered pair, negative 2, negative 4, is a solution for this equation. Well, you can try things like 0. You can plug in a 0 here for x as an input. So 3 times 0 plus 2. The result, of course, is 2. So the ordered pair, or another ordered pair that works for this equation, is 0, 2. And you can check it by putting it in here, and it would work. You can try a point like 1. If x were 1, what would the value of your function be? The value of your function is just the output. or the range. So in this case, you have 3 times 1 plus 2 is 5. We're looking at 1 paired with 5. Again, if you go back up here, you can plug it in, and you'll see that that's true. If x is 1, then y is 5. Cool. Now, we have this relation, and it turns out to be a function, and we have the relation that's described by this rule right here, this equation. All of these xy pairings are true for this equation. Well, we can represent these pairings that are true for the equation by graphing them. So if you have -2, -4, that's the point right here. If you have the point 0, 2, that's the point right here. And if you have the point, what is this, 1, 5, that's the point right here. Cool. Oh my goodness, these happen to make a straight line. In fact, let's think about what would the value of the function be if you looked at -1. If you looked at -1, plug that in for x up there in the original equation, and you'll see that y has a value also at -1. And now it's more clear to see that these points seem to be following a straight line, like so. We've just graphed a visual representation of all the solutions to the equation y equals 3x plus 2. This is important, very important. What we've done here is we've shown a visual representation of all the possible points, like these ones, that we know work because we did the math, but the line, if we pick any point on this line, like this point right here, this is the point 2, 8. If a point lies on this line, if the line is straight and drawn accurately, if a point lies on this line, it will satisfy the above equation that the line comes from. Let's take a look. You've got the point 2, 8. Looking at y equals 3x plus 2. If you take the 2 from this point over here and you plug it in, 3 times 2 plus 2, what is that? Well, guess what? It's 8. And this is, we know this must be true because 2, 8 is on the line and satisfies the equation. Cool beans. Why don't you try one? You've got the equation y equals -2x plus 1. And what we want to do is we want to find out what values for x and y will make this idea true. And if we graph this idea, we can find out all of the xy pairings that will make this statement true. If we start, we can find the trend by putting in any arbitrary number for the input or the independent variable. What I want you to do is figure out what the value of your function would be at these values here and come up with the xy pairing. I'll start you off pretty easy. If you put in a -2 in for x, be careful, use parentheses, you can see that the value for y would be 5. -2 times -2 is 4 plus 1 is 5. So the pairing would be when x is -2, y has a result of 5. You can go to the graph and plot that, -2, 5. Pause the video and see if you can come up with the right points, and we'll graph them together as you resume. Pause. I said pause. Pause it. Here come the answers. Okay, so you can see that after I plug in each of these values, -2, -1, 0, 1, and 2 for x, I get a specific y. As I plug in 0, I get a 1 for y. after I do the function rule. The rule is to take x, multiply by -2, and then add 1. If I do that, of course, I get 1. If I plug in a 2 to the above function rule here, described by our equation, if I plug in a 2 for x, the input of 2, then I get an output of -3. When I plot all these points on our graph, 1, -1, 3, 0, 1, 1, -1, and 2, -3, you can see the pattern developing. Seems to be a straight line. If you draw a straight line through these points, this is the graph that represents every possible solution to the equation written above. Let's do the thing where we select a point. If this line is drawn straight, it should be going through all the good points that satisfy the equation. And it's not drawn very straight, but we'll pick a point anyway. So this point here should be on the line. And if it were, then it would work for this equation boxed in red. The equation -2x plus 1 is equal to y. So the point that's on the line, this point right here, -3, what is that? -3, 7, should work. If you put in a -3 here for x, you should get the result of 7. 6 plus 1, 7. Oh my gosh, this makes sense. Okay, humans, sometimes the equations are really hard to graph, or to think about at least, initially. But you'll see how this makes sense. X is equal to 8. Well, I guess there's no arguing with that. If we're told that x is equal to 8, that means that x, the value for x on your graph, must be 8. So here's the value, x being 8, and I guess x must always be 8. Where is x also 8? Above this point. Where is x also 8? Here, here, here. All of these points that I'm graphing right now on this vertical line have the form where their x value is 8, but their y value is the thing that changes. So where is x 8? Well, x can only be 8 on this vertical line that goes through 8 on the x-axis. Cool beans. Well, analogously, if you're looking at the graph of y equals 4, let's say, if we're on the xy coordinate plane, where is, if this must be true always, y is 4. Y is 4. Well, y is 4 right here. Where must y always be 4 if you go horizontally? Kind of counterintuitive here, but it makes sense because all of these points that are on this red line are of the form some idea for x, but the y value is always 4 if you're on this line. Hopefully that makes sense. Like this point here. This point is the point 2, 4. Whereas this point right here is the point -1, 4. Notice the y value is always 4. Just like up here, this value might be 1, 2. It might be 8, 2, but notice the x value, always 8. Cool beans. I hope you enjoyed this. Like and subscribe. No, I'm just kidding. You don't have to do that. But you do have to think about mathematics. Mathematics is cool. This will help you describe the universe. It'll help you recognize patterns. It'll help you be more logical. It'll help you be more funny because you can connect ideas really quickly. Yeah.